One of the great things about the Department of Civil and Environmental Engineering at Lehigh is that we have the strengths of being at a small university, and yet we have great research going on in 4 different concentrations. So we have geotechnical, structural, environmental, and water resources, which is my area of expertise. It's an exciting time to be doing water-related research here at Lehigh. We have research spanning from the impact of climate on flooding to how to improve drinking water supplies in the developing world. I have 2 main research interests, both of which are linked to climate, hydrology, and society. The first looks at flooding across large river basins and how that's linked to large-scale climate states. The second looks at sustainable water resources, because in many parts of the world, how much water you have is inextricably intertwined with the food production going on. Irrigation is the largest consumptive user of fresh water, both in the US and globally. From an agricultural perspective, this can make the difference between a successful or a failed harvest, because irrigation allows us to buffer against climate variability, and it also allows us to grow crops where we otherwise wouldn't be able to, given how much rainfall we get. From a water resources perspective, irrigation can be problematic, exacerbating water scarcity, often in regions that don't have very much water to go around. Climate variability just complicates this relationship. During dry years, there's less water, and yet this is when crops are going to need more irrigation to survive. So if we look at this system as a triangle of relationships, climate, water, and food, then we can study this system as a whole or look at its individual components. I use a hydrologic model that simulates the water cycle over land. It includes crop growth and irrigation water demands, and this allows us to evaluate sustainable or unsustainable water resources over the land, including the impacts of irrigation water withdrawals on stream flow. This allows us to evaluate the impact of human activities on the water cycle, but it also lets us run scenarios. For example, what would happen if rice production is decreased? How much of an impact would this have on water resources? Some of my research has focused on using statistical methods to evaluate the impact of climate extremes, like drought or heat wave, and how they negatively impact crop yields, and whether or not this effect is different depending on whether the crop is irrigated or rain-fed. This research provides us with critical information for decision-making in the coming decades. Populations are expected to increase, and climate change is expected to be accompanied with changing frequency and magnitude of extremes. Both of these things are going to put pressure on our water and food systems, and research like this is going to allow us to be better prepared for the coming future.